Today we move on to the chapter Motion and Time, part 3. Our topic is simple pendulum. What is simple pendulum? Simple pendulum consists of heavy point mass that is called a bob, which is suspended from the fixed point by using thread, and it is allowed to swing freely, allowed to move freely. This setup is called simple pendulum. In order to learn simple pendulum, there is 4 important terms which are necessary to be studied. The first term is length of the pendulum. It is the distance between the point of suspension and the center of this bob. It is denoted by L. What is distance? What is the length of the simple pendulum? It is distance between this point of suspension to the center of this bob. Next term is oscillation. It is nothing but oscillation should to be one complete vibration of this pendulum, that is to and fro or to and back motion of this bob of this pendulum. The next term is amplitude. What is amplitude? It is the maximum distance or maximum displacement of this bob from this main position to the extreme position. When you vibrate the pendulum moves moves on both the sides. So this distance from one side to the mean position, that is called maximum displacement or distance of the from the center of the mean position to the movement of other side, that means extreme position. It is called amplitude. Next important term is time period. What is time period? Time taken to complete one oscillation or time taken to complete one to and one fro back motion of the bob or simple pendulum is called time period. There is one important thing to be remembered, that is when the length of the thread in which bob is attached, if the string length is longer or it is greater the length of the pendulum, then the time taken will be more. Time taken for completing one oscillation will be more. If the length of the string in which pendulum or in which bob is suspended, if it is short length, then the time taken will be very less. Time taken of the simple pendulum, time taken by the simple pendulum depend upon the length of the string in which bob is suspended. Here is an activity 3 is to measure the time period of this simple pendulum. Here we are going to show the time taken, how long it takes to complete one oscillation. For this you are going to take 30 centimeter length of the string with a bob attached to its one end. Now just strike this bob, it start oscillation. Now note on the time taken to complete one oscillation, that means 1, 2 and back and come back to the mean position. That is called one oscillation. Now note down the time and repeat the same activity by changing the length of the string from 30 to 15 centimeter, 15 centimeter. Now you note down the period. Again you do oscillation and note down the time taken to complete one oscillation by this 15 centimeter length of the string. What do you observe? In second case, the time taken will be very less. In first case, time taken will be more because length of the string is more in the first case, so time taken will be more. In the second case, length of the string is only 15 centimeter. The length is shorter than 30 centimeter, so time taken will be very short. This activity clearly tell you that time taken for the one complete oscillation depend upon the length of the string in which bob is attached. We are moving on to the topic units of time. There are different units of time like hour, minute, second, etc. We know that each day is divided into 24 hours and each hour consists of 60 minutes as well as each minute consists of 60 seconds. 1 means solar day equal to 24 hours equal to 24. How will you convert 24 hour into minutes? You have to multiply 24 into 60, then you will get the answer and convert it into minute. Next, if you want to convert this hour into second, you have to multiply first into 60. So it changed into minute. Again you convert this minute into second. For converting minute into second, you have to multiply again this value into 60. Then you will get the answer in seconds. 1 second equal to 1 by 86,400 mean solar day. This unit you have to remember. The SI unit of time is second. Also you know that 1 decade consists of 10 years. Then 10 decade consists of 100 years. The same way 1 century means 100 years. Then 10 century means 1000 years, which is 1 millennium. Now we are going to represent time taken and the speed of the object moved in the form of graph. What is graph? Graph is a pictorial representation of two variables in the form of straight line or curved line, in which one varies as a result of change of other variable. When we learn this graph, we come to know what is that. Look at this. This is called graph, in which two variables are mentioned denoted in x-axis and y-axis. Here time and distance is, these two variables are mentioned here. If any one of the variable like distance, if the distance is changed, definitely time is also changed. So this graph shows variation in change in one of the variable with respect to other variable. The graph studying graph help us to find out the distance or speed. If you take this distance time graph, we come to know the speed of the object moved. As we all know that speed is equal to distance per time. By calculating this, we can come to know the speed of the object by using this graph. These are the different graphs which shows uniform and non-uniform speed of a moving object. This is a graph showing uniform speed because the object moved in equal distance in equal interval of time. Here an object moved first 5 km in 10 minutes, and from 5 to 10 km the object moved in again 10 minutes. So equal distance the object covered in equal interval of time. That is what this graph shows. This graph plot the uniform speed of a moving object, whereas this graph shows non-uniform speed of a moving object because the object covered different distance in fixed interval of time. The interval of time is 10 minutes, but the distance covered is different. First 10 minutes it will cover 2 km, again 6 km, again it is 2 km, again it is 6 km, like that variation in distance in fixed interval of time. That is what this shows plot non-uniform speed of a moving object. In this graph up to here it shows uniform speed. Then the object is not moving, it will remain constant. That is what not changing position, it is in stationary position. And again from here to this position, it shows uniform speed. Likewise, different graphs shows different information about the variables, different variables.